You are welcome to today's class. We shall be discussing the mutually exclusive events in this class. We are still on the topic probability. Don't forget, in our last class we discussed the definition of probability. We discussed some terms like events, sample space, outcomes, etc. So in today's class, we shall be talking majorly on mutually exclusive events. In our subsequent videos that I'll be sending to you, we shall be talking about the independent events. Okay, quickly, when we say two events are mutually exclusive, it means they cannot exist together. They can only exist separately. So we use the term or. So when this happens or this happens, then these two events, call them A and B, are mutually exclusive when they don't happen together. Alright, so one event will pave way for the other. In such a case, the separate probabilities are added together. Probabilities are added to give the combined probabilities. So when we have two of such probabilities that are mutually exclusive, when they don't happen together, we add them together under this topic. Alright, so let's talk about the addition law of probability. Now, the addition law of probability is basically used when we discussed or when we are discussing mutually exclusive events. For instance, if events A, B, C are mutually exclusive, the probability of A or B or C happening is the sum of probability of A, probability of B, probability of C. And that's what you can see here. This P of A, P of B, P of C actually means probability of A, B, C respectively. Okay, don't forget I said when you see the word or, it means we are actually dealing with what? Probability. Now let's talk about, okay, it says use the addition law to solve problems that contains the word or. Like I said earlier, when you see either or when you see or, it means the events are mutually exclusive. Then what we do is to add the combined probabilities together. So one example is this. It says a bag contains 3 red balls, 4 blue balls, 5 white balls, and 6 black balls. A ball is picked at random. What is the probability that it is either A, red or blue? Can you see that? When you pick one ball from a bag containing a number of balls of different colors, what of that this happens or this happens? Can you see that? So when you hear or, of course you should know that what you need to do is add individual probabilities to give a combined probability. Now the first thing to do is find the sample space. As I taught you in last class, sample space is found by summing together the total available or total possible outcomes. So we have 3 balls, 4 balls, 5 balls, 6 balls, and that gives a total of 18 balls in the bag. Therefore, our sample space is 18. Now, the required outcome for A, red or blue. So find the probability of having all the kind of balls. Probability of having a red ball is 3 over 18 because we have 3 balls out of 18 balls. Probability of having a blue ball is 4 over 18. A white ball is 5 out of 18, and let's call that a black ball. Let's use BK for black because we already have B for blue. Do you understand? So for a black ball, we say we have 6 of them out of 18, so 6 over 18 is the probability for having a black ball. Okay, so let's quickly talk about A. What is the probability that the ball picked is either a red or a blue ball? I told you you have found the probability of red ball to be 3 over 18, probability of having a blue ball to be 4 over 18. So probability of having a red or a blue, we add the two probabilities together. That's what? 3 over 18 plus 4 over 18. Now we do this by finding the LCM of the denominators, like we add common fractions. The LCM of 18 and 18 is of course 18. So if you add these two together, you have what? 7 out of 18. That's 7 over 18 is the probability of picking a red or a blue ball. B. What's the probability of picking a blue or a black ball? Of course, the same way, probability of picking a blue ball is 4 over 18. Can you see that? And probability of picking a black ball is 6 over 18. Of course, the same thing happens. When you find the sum, you have 10 over 18, which you can give to the lowest term to be what? 5 over 9. Since 2 goes in 10 and 2 and 18, sorry. Alright, for C, probability of having a red, white, or blue ball. Now, if you pick a red ball, that probability is what? I know your mind, you have said 3 over 18, and for white, 5 over 18, and for what else? For blue, we have what? 4 over 18. If you find the sum, you have 12 over 18, which is 2 over 3 in the lowest term. For instance, for C, 12 over 18 gives 2 over 3. Now for D, the probability of picking a blue, white, or black the same way: 4 over 18 plus 5 over 18 plus 6 over 18, and that gives us 15 over 18, which is 5 over 6 in the lowest term. 3 in 15, 5, 3 in 18, 6. Alright, this one you have to take note of E. Whenever you see probability of neither nor. Now, probability of neither a red nor a blue ball is picked. I explained this in last class that when you have probability of, when you have to find probability of failure, I said probability of success plus probability of failure gives 1. So probability of failure is 1 minus probability of success. Same thing, probability of success is 1 minus probability of failure. So probability that we have a red or blue plus probability that we don't have a red or blue is equal to 1. Therefore, probability of not picking a red or blue is 1 minus probability of picking a red or a blue. Let me come again. What I'm saying is this, that if the probability of an event not happening or an event happening is known, then the probability of an event not happening is 1 minus probability that it happens. Can you see that? So what I'm saying, and I explained that in the last video, I believe that's clear to you. So when you're asked to find the probability that an event does not happen, can you see? Probability that neither red or blue is what? 1 minus probability of picking red or blue. So you can find probability of picking red or blue. Red or blue. Have we found that before? In A, let me see. We found that in A, and we got what? 5 over 9 or 10 over 18. Had it been you've not found it, you have to find it by yourself. You calculate that one, then you do 1 minus that. 1 minus 10 over 18, and that will give us what? 7 over 18. How do you do that? 1 over 1 minus 7 over 18. Find the LCM, that's 18. Then do your normal fractional process. You have 11 over 18. Okay. Another way of doing this is this. If you have been asked that find the probability that the ball picked is not red or blue. Now, if the ball picked is not red or blue, of course, then the ball in that bag we have white, black, red, and blue. If the balls are not red and they're not blue, then it should either be white or black. Therefore, it means the ball can be either white or black. Now, using the or, probability of white plus probability of black, can you see that? And that will give us what? Probability of white is what? 5 over 18. Probability of black is 6 over 18. So if you sum the two, you still get 11 over 18, which I think is the same thing as what we got at E. That's clear, I expect. Alright, so let's quickly do example 2. It says a letter is chosen at random from the word computer. What is the probability that it is A, either in the word court or in the word rope? Of course, in the word computer we have 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 letters in the word computer. Had it been 2 letters repeat themselves, we wouldn't say we have 8 letters. We will still say we have, and we wouldn't say we have 8. We will say we have 7. When 2 letters, like had it been we have O and O coming twice, and if you count the whole digits, we still have the whole letters. We still have 8. But because one repeats itself, then we have 7 entries. Do you understand? 7 different entries. We don't repeat entries in probability and set. Don't forget. All right. So in computer we have 7 and we have 8 letters. So number of elements now sample space is what? 8. So sample space is 8. Can you see that? All right. So A, I want to find the probability that when a letter is chosen, that letter should be either in the word cut or in the word rope. Don't forget, or means what? Addition. In cut, how many words do we have there? We have 3. In rope, we have 4. So that is 4 over 8 plus 3 over 8. Can you see that? So we have 7 over 8. Very simple. In cut we have 3. In rope we have 4. So that gives us 7 over 8 when we find the addition. Also, in the word property, okay, what is the property that the letter chosen is not in the word met, nor is it in the word up? Can you see? Neither in the word met or up. Met has 3 letters, up 2 letters. So when you see not, 1 minus that it is. I told you before. So that's what. In met, how many letters we have? 3 in word. We have in up we have 2. That's 3 over 8 plus 2 over 8. That gives us 5 over 8. So you do 1 minus 5 over 8. That gives us 3 over 8. Very simple, like we did in the last example. I think that's clear. So your assignment is this, and to do the evaluation, and I believe the class is clear. Thank you, and do have a nice time.